Okay, in the next video we're going to talk about determining the total suction superheat, which is an important check for any service tech. So what we want to check, what we're essentially checking is, once we know the saturation point on the low side, being the condition that the refrigerant vaporizes from a liquid to a vapor, or evaporates or boils off, the boiling point of that particular refrigerant, how much additional heat it picks up, not only in the evaporator but also in the suction lines, the total suction superheat. So it's how much superheat picked up in the evaporator, which should ideally be about 6K, and how much additional heat down the suction line, which will vary slightly from application to application, but we don't want it to be any more than about 10K. So we're at a blast chiller here. Got an old Lightfoot compressor, an open drive compressor. We're actually running on ammonia, which is R717, a natural refrigerant. And anyone that works with ammonia or knows anything about ammonia knows we need to exercise extreme caution when working around ammonia. Albeit that it's a great refrigerant, which it is. It's been around since the start of time for fridges. And it can be harmful if we don't exercise that caution. We don't have the knowledge of how to work around it. So if I was to walk into this room, if there was an ammonia leak, I'd be able to smell it a mile away. It brings with it a very strong smell, a smell that you don't experience with R22 or R404A or 410A134A, which don't have an odour, but can be just as harmful because they will displace oxygen. But ammonia you can smell a mile away, so you don't go running into it, because it will, for starters, take up the moisture in your eyes because it's anhydrous ammonia. Alright, it's not aqueous, it's anhydrous. Moisture in your lungs. But any ammonia plant, there's strict guidelines, and you can see here we've got an ammonia sensor which will send off a bell outside. If you do get any ammonia on you through an accident, head straight for the wash station, wash it immediately with water. But that's another story altogether. See, ammonia also, we've got steel pipes because ammonia reacts with copper and brass and it eats it away. Bit of copper pipe here, but that's for water. We've got water jackets in the head. With ammonia we get extremely high discharge temps. Fortunately for the industrial side, the industrial fellas have kept ammonia alive and well. Alright, but total suction superheat, doesn't matter if we're working with ammonia or R22, what it may be. We want to determine the saturated conditions on the low side for starters. Now with any superheat check, especially evaporator superheat, you just don't go, if we've started up a new plant, you've just turned it on, we just don't go checking the superheat and start ripping the valve open, the TX valve that is. Because a true superheat check needs to be done when the plant's down near desired conditions. If you do it when you've just kicked it on, you've got all the humidity in the air and whatnot, you're going to get a large superheat. So it's going to put you under the... You also want to make sure you're running at the right head pressure. Just don't go ripping a TX valve open willy-nilly. Because what happens is when it comes down to running conditions, you start flooding, wash out your oil, start bending valves, whatnot, and you end up with a crook compressor. We'll just run through the rigmarole of a total suction superheat. Now I've only just started this plant up, so the total suction superheat is going to be large. The evaporator isn't actually in, we've got an old evaporator here, isn't actually in a conditioned space, an insulated box, where it normally would be, because we've got this plant for training purposes only. NH3 here is ammonia. The refrigerant number for ammonia is R717 also. So, I want to know, I've got my saturated condition here, I want to know what the boiling point is, and I want to know after the boiling point how much heat I've picked up above the boiling point, which of course is a superheated vapour. So after we add heat above saturation, the refrigerant's in a condition known as superheated And this superheat check is an extremely important check. It tells us a lot about the characteristics of the plant. It tells us whether we're sending liquid back, it tells us whether we're picking up too much superheat in the evaporator, that is, we're not using the evaporator to its full capacity, it's not fully wetted. It tells us if we're picking up too much superheat in the suction line. It's a total suction superheat. So first of all, now fortunately for us, we've got a transducer here on the suction. We've also got a thermistor. Normally you'd have to fit gauges, and we'd like a thermocouple to get an accurate reading of the temperature of the refrigerant entering the compressor. So the boiling point, suction pressure, we're sitting at about 170 kPa, so R717, 170, it's about 172, minus 22. So we're boiling at minus 22. That's our saturated condition. Now, we do have a 1K pressure drop in the suction line, but for the purpose of determining this, minus 22. Suction temperature of compressor, -27, so it's huge, minus 22 and 27. The difference with those two is because it's 49K, so that's massive, completely unacceptable. I would expect a large superheat under these conditions because I'm out here in the open at a training plant. Now out in the field immediately we would check the evaporator superheat, and we would begin to open up the 2X valve. Now this 2X valve could certainly be opened up slightly. The total suction superheat will determine how much superheat was picked up in the evaporator and how much superheat was picked up in the suction line. We would expect between 10 and 15K all up. I've got 49, completely unacceptable. It's certainly no good. A very important check. It's one of the TDs that's going to help you diagnose problems and commission the plant properly in the future. On top of your evaporator superheat, your evaporator TD, condenser TD, how much subcooling you're providing, the condenser's providing, because you need to know that for sure. You need to know that you're not providing too much subcooling, that you're going to get liquid binding, and too little that you're actually flashing off before you hit the TX valve. So yeah.